Good evening, students. Today's topic is chemical kinetics, rate law and rate constant. We have discussed about rate of a reaction in the previous class. So today we will continue with the second part. Let us take an example, a reaction like this. So in this reaction we can see that A plus B plus C gives us the product in which small a, b, c represents the coefficients. Now what is a rate law? A rate law is an equation which gives the relation between rate of reaction as well as the concentration of reactants. It says that the rate of a reaction is directly proportional to the concentration, you can represent in square bracket, the concentration of reactants. Fine. Now if you take in the given equation, we can write like this. The rate of the reaction is proportional to, here we have A, B, C as reactants. You can write like concentration in square bracket, and coefficient is written as power here, into concentration of B to the power of small b into concentration of C to the power of small c. So this rate is directly proportional to the concentration of A to the power of its coefficient and so on. To remove this proportionality symbol, we can write a constant k. That k is nothing but rate constant. So A to the power A, B to the power B, and C to the power of C. So this is represented by the rate law. Now let us discuss about the k. What is k here? K is known as rate constant or velocity constant, or you can also call it as specific reaction rate. So we can call k in these terms. Generally we use rate constant. Now let us see what will be the unit of rate. We already know that is nothing but mole per liter per second. Let us derive what is k now. So if you want to write like this, rate is equal to k into, so the concentration of reactants, like this, let us see. Now you have A, B and C. We have written as power. So let us represent it as to the power n, where n is equal to, we can say A plus B plus C. How to get k here? K is equal to, by sending this to other side, we can write it as rate by concentration of reactants to the power of n. Fine. Now let us give one example for this. If you are taking Haber's process, N2 plus 3H2 gives 2NH3. In this, let us write the rate law. It says that the rate is equal to K into the reactants alone we will take, N2 concentration into H2, coefficient is 3, therefore we'll write to the power of 3. Now very important thing here, what is the power represented as? The power is represented as order of reaction. So one more important term, order of reaction. We can say that with respect to this, like concentration of N2, the order of reaction with respect to N2 is 1, with respect to hydrogen is 3. So what is the overall order of reaction? Overall order of reaction is nothing but 1 plus 3, which is equal to 4. Okay. So we will see more examples. If at all you are talking about overall order, If it is 1, you call it as first order reaction. If it is 2, you call it as second order, and so on. So in such cases, how to find a K here? We can write like this: K is equal to rate by concentration of N2 into H2 to the power of 3 here. So we can very easily note this. There is one formula also which we will discuss later, but when you write like this, concentration per second divided by, for N2, mole per liter, and here you have mole per liter to the power of 3. So hope you are able to follow this. Depending upon the reaction, you can write the rate constant. So rate by the concentration to the power of the coefficient. Now in this condition, you can easily calculate the units for rate constant in this Haber's process. So hope you have understood this. Let us solve some numericals. So we have two questions here. The first one says a plus 2b gives c, obeys rate law, and the rate is given as k into a to the power of 1 by 2 and b to the power of 3 by 2. They are asking to calculate order of reaction. So we know that rate is equal to k into a to the power of 1 by 2 into b to the power of 1 by 2. So order of the reaction is equal to, suppose you are taking like this, rate is equal to k into a to the power of, you can take a into b to the power of b. Now order is equal to a plus b. We know this. Similarly here also order is equal to 1 by 2 plus 3 by 2. So we will get 4 by 2, which is equal to 2. Now order of the reaction in the first case is 2. So this reaction is known as second order reaction. Coming to the second question, they are asking find out the order of reaction for the following two equations. So take the first one, 2NO2 gives 2NO plus O2. Rate they have mentioned. What is the rate? Rate is equal to NO2 to the power of 2. Very simple, we know this. The power of this particular concentration is nothing but order of reaction. So therefore we can write it as order is equal to 2. Now for this they have given the rate is equal to K into C12H22O11. So the reaction inversion of cane sugar, where you are converting sucrose into glucose plus fructose, the rate is equal to K into the concentration of sucrose to the power of 1. So very simple, here the order of reaction is equal to 1, and this is considered to be the first order reaction. Now let us move to the next question. Now question number 3 and 4, here a very simple thing, we will see another formula to calculate the order of reaction. It's the second type of question. They will give you the rate constant, and with the units we have to calculate the order of reaction, because here we don't have the rate law, we only have the unit here. So both the questions we have to solve using formula. So what is the formula here? How to find out the order? The order can be calculated with the unit. How to find the unit? That is mole 1 minus n, liter is n minus 1 and s minus 1. So order can be identified by using this, where n is equal to order of the reaction. So we can find out the order using this particular formula. So now first one. So in this condition they have given mole minus 1, liter is 1 and minute minus 1. It can be second or minute. Now let us see the first two terms. 1 minus n is equal to minus 1. So therefore send this to other side. 1 plus 1 is equal to n. So therefore n is equal to second order reaction. So hope you have understood. Applying this formula, using the unit we can calculate order of reaction. If you want second one also you can identify. What is that? L to the power of 1, and if at all L you are taking, it should be n minus 1. Therefore n minus 1 is equal to 1. So send minus 1 to other side, you will get order of reaction is equal to 2. With the mole or with the liter you can get the order of the reaction. For the third we have calculated. Now come to the fourth question. You are given 3 values. What are the 3 values of rate constant? First one, the unit is mole minus 1, L1 and S minus 1. Let us take mole minus 1 alone. So we can see that 1 minus n is equal to minus 1. So send this to this side, what we will get? 1 plus 1 is equal to n. So therefore this is second order reaction. Next, what about the B? Here they have given just S minus 1. That means we can say that mole will be 0 here. So 1 minus n is equal to 0. Send it to other side. So therefore 1 is equal to n. So we can say that this will be coming under first order reaction. This is second order reaction. Now the last one, that is they have given K value as 8.6 into 10 power minus 3 mole L minus 1 and S minus 1. Again you can take, so mole to the power of 1. That means 1 minus n is equal to 1. So send this to other side. 1 minus 1 is equal to n. Therefore you can say that n is equal to 0. So the last one comes under 0 order reaction. So hope you have understood this. So we can calculate order of the reaction when unit is given applying this particular formula. Now let us move to the next questions. Now let us say review exercise questions 4.20 and 4.27. See, these two questions are similar. First let us solve 4.20. Here they have given the equation, for that rate is given and then rate constant is also given, and they are asking to find out the initial rate of reaction. So according to the rate law you have this equation. Let us write rate is equal to K into concentration of A into concentration of B square. So this is given, and just we need to substitute the values here. What is rate constant? 2 into 10 to the power of minus 6. Now concentration of A is 0.1, here only 1, so to the power of 1. Now concentration of B square, so nothing but 0.2 whole square. Now that is equal to, keep 10 to the power minus 6 as such and write 2 into 10 to the power minus 6 into 0.1, we can write 10 to the power of minus 1 into, this is nothing but 0.2 into 0.2. So we can also write it as 2 into 2, 4 into 10 to the power of minus. So simple calculation only. Finally what we will get, that is equal to 2 into 4 into 10 power minus 6 into 10 power minus 1 into 10 to the power of minus 2. Whole thing will become, so 6, 7, 8, 9, 10 to the power of minus 9. Now the unit of rate we know, mole L to the power of minus 1 and S to the power of minus 1. So this is your rate. Hope you have understood this. Similarly 4.27, same formula we have to apply. So K value, what is K here? Same thing, 2 into 10 to the power of minus 6. Now the concentration is of A is given as 0.2. What is the concentration of B? 0.1. Once again square. That is equal to 2 into 10 to the power of minus 6. This we can write it as 10 to the power of minus 1 into 0.1 into 0.1. This whole thing will become 10 to the power of minus 2. 2 into 2, 4. Now minus 6, 7, 8, 9. 10 to the power of minus 9. So what is the unit of rate here? Nothing but mole L to the power of minus 1 and S to the power of minus 1. So hope you have understood this. So important thing. So applying the rate, we can get the initial rate of the reaction. So this is one type of numericals. Now important thing is, what is the difference between order of a reaction using the equation as well as experiment? Let us do some numericals. So now a very important question we are going to discuss. See, due to the experimental data, they have performed 4 experiments by taking different concentration of A and different concentration of B in this particular reaction. So 2A plus B gives C plus D. But with the theory what we were writing it as rate is equal to K into, here 2A is there, therefore A to the power of 2 and B to the power of 1. So till now we were discussing based on the stoichiometric coefficients, we were writing the rate law like this. But actual rate law should be written only based on the experimental data. So let us see how we have to write that. We know general method, rate can be represented as K into, we can take A to the power of X and B to the power of Y, where X is nothing but order of reaction with respect to A and Y is order of reaction with respect to B. Let us first calculate what is X and what is Y. I'll give a very simple hint here. To find X, first let us see how to calculate X. To find X, we have to see in the data same values of Y. So where we can see similar values of Y here, like that we can write. Here 0.1 and here we have 0.1 concentration. So same concentration of B, that is to the power of Y. If you take that particular equations will give you the value of X. So first for equation 1, can we write R1? So this we are taking R1 is equal to K into, so we can write A can be 0.1 concentration to the power of X and here it will be 0.1 to the power of Y. Now this fourth one, R4 is equal to K into, here we have 0.4 to the power of X and here it is 0.1 to the power of Y. So we have taken the two equations where you are having similar concentration of B to the power of Y. So let us write that equations. How to write? You can take it as, see, more value divided by less value. So hence rate 4 by rate 1, what we will get? K into 0.4 to the power of X. Here it is 0.1 to the power of Y divided by K into 0.1 to the power X and 0.1 to the power of Y, which is equal to, what is R4? This is R4, nothing but 2.4 into 10 to the power of minus 2 divided by, what is R1? 6 into 10 to the power of minus 3. Now let us calculate this. So what we get? K, we can cancel 0.1 to power Y, cancel this. So what you will get here? Nothing but 4 to the power of X. We are getting 4 to the power of X is equal to, so this we can cancel it, 6 ones and 0.4, nothing but 0.4 into 10 to the power of minus 2 into 10 cube. I have sent minus 3 to the numerator becomes plus 3, so therefore we will get, here we have 4. So answer is 4. So we can write it as 4 to the power of x is equal to 4. So hence x is equal to 1. So here x is equal to 1. Very simple. To find x, what we have done? We have taken the similar concentration of b to the power of y. So we got the value of x as 1. So let us substitute x is equal to 1 in our rate law. Now next, hope you have understood this. Second one, how do you find y? So if you are calculating x, you took same values of y. Now to find y, we can take the same concentration in a to the power of x. So same values of x we can take. So what are those same values here? These two. So 2 and 3. Let us write like this. R2 is equal to k into. So here what is a? 0.3 to the power of x into what is b here? 0.2 to the power of y. I have taken 2. Next R3. R3 is equal to k into here 0.3 to the power of x, and then here you have 0.4 to the power of y. Hope you have understood this. Same concentration will be cancelled out. That is why we have taken R2 and R3. Now we can equate that. So 4, we can take it as numerator and write R3 by R2. Very simple, because 4 by 2 we will get 2 there. So we have taken nothing but k into 0.3x 0.4y by k into 0.3 to the power of x into 0.2 to the power of y, which is equal to, what is R3 here? 2.88 into 10 to the power of minus 1. And what is R2? 7.2 into 10 to the power of minus 2. Next. So in this k 0.3 to the power of x will be cancelled out. Next, this will become 2 to the power of y is equal to, now we can calculate this. If you convert this into 10 to the power of minus 1, you can do, otherwise also directly you can cancel. Let us take 0.4, moves up, it will become 2, so nothing but 4. So you will get 2 to the power of y is equal to 2. Can we write like this? 2 to the power of y is equal to 2 square. 4 can be written as 2 square. Therefore, y is equal to 2. So very simple. Now we can substitute y as 2. So hope you have understood. We got the rate law. What is the rate law? Rate is equal to k into a to the power of 1 into b to the power of 2. Next. So they are asking you to find the value. So let us write down the values here. Substitute any of the equation, then you can calculate the rate value. So first one, find the rate law. So we can write rate is equal to this. That is equal to, so k value we can identify, no problem. Equation 1, R1 you take. What is R1 here? 6 into 10 to the power of minus 3. So 6 into 10 to the power of minus 3 is equal to k into, we can take a is 0.1 to the power of 1, and what is b? Again 0.1 to the power of 2. Now let us send this to other side. What you will get? 6 into 10 to the power of minus 3 by, can we write 0.1 as 10 power minus 1? And here you have 2. So I will write 10 to the power of minus 2 is equal to k. So send this denominator to numerator, minus 3. So you can cancel here itself. So therefore k is 6. So what about the unit here? So unit let us write. So the rate is nothing but mole into L minus 1 into minute minus 1. And what is the concentration here? Mole into L minus 1. We have 1 and 2. So totally we can write to the power of 3. So hence what we can do, we can cancel out with 1. So here you will get 2. So what will be the unit here? Finally we can write like this: mole minus 2, and L is, here we can have minus 1, means you will get a plus 2, and minute minus 1. So we got the value of K like this. So rate constant we have calculated, and rate law also we have calculated. Now in addition to that, if they are asking you what is the overall order of reaction, then we can say that order is equal to 1 plus 2, nothing but 3. So this is coming under third order of reaction. So hope you have understood this. Let us solve one more question. Now the last question, let us see another method where they have done 3 experiments with the different concentration of NO and chlorine. So they got NOCl. So in this reaction, so they have given the rate at that particular concentration, and they are asking us to find out rate law, order, and K. So first let us write what is the rate here. Rate is equal to rate constant into, so the concentration of NO to the power of X into the concentration of Cl2 to the power of Y. So this is general rate law what we have taken. Now again apply the same thing, that is first one to find out X. What we have to do to find out X? Observe here in this second concentration where you are having similar values. So therefore we can take R2 as well as R3. Let us write what is R2. R2 is equal to K into NO will be 0.01 to the power of X, and here we have 0.02 to the power of Y. And what is rate here? The rate can be written as 2.4 into 10 to the power of minus 4. Next, R3 is equal to K into 0.02 to the power of X into 0.02 to the power of Y, and the value is 9.6 into 10 to the power of minus 4. So with this what we can do, the maximum values we can take, that is R3. So let us take R3 divided by R2. So we can write like this. So K into 0.02 to the power of X into 0.02 to the power of Y divided by K into 0.01 to the power X into 0.02 to the power Y is equal to. Now the rate R3 value is 9.6 into 10 to the power of minus 4 divided by R2 value 2.4 into 10 to the power of minus 4. Very simple. According to the formula we know, like to find X we have taken similar values of Y concentration. So cancel that, K also gets cancelled, and here what you get, 2 to the power of X is equal to 10 power minus 4 gets cancelled. So this will be 4 times. Now we can write 4 as 2 square. Therefore X is equal to, very simple, we have found that value of X is equal to 2. So therefore we can substitute here. So order of reaction with respect to NO is 2. Now next, how to find Y? Second step, we need to calculate Y. So the method is same. What is that? Here we have to see what is similar concentration. So to find Y, we should check that which is similar here. So let us take R1 and R2. So what is R1? K into the concentration of NO is 0.01 to the power X. We know already X is 2, no problem. And here it is 0.01 to the power of Y. R2 is equal to K into 0.01 to the power X into here it is 0.02 to the power of Y. And values also you know, 1.2 into 10 to the power of minus 4, and here it is 2.4 into 10 to the power of minus 4. So first we have written the equations. Next, which one is bigger value here, that you see. So we can say that 2.4. Hence what we can do, R2 divided by R1 we can take, we will get value easily. So what is R2? K into 0.01 to the power x into 0.02 to the power y divided by R1 is K into 0.01 to the power x into 0.01 to the power y is equal to 2.4 into 10 to the power minus 4 by 1.2 into 10 to the power of minus 4. So we have written the required equation. Next, cancel similar values. Here 10 to the power minus 4. What we get? 2 to the power y is equal to 2. So very simple. We can identify that y is equal to 1. Order of reaction with respect to y, that is Cl2 is 1. So this will become your rate law. So hope you have understood this. So we have calculated x as well as we have calculated y. Now what about the second question? The second question is they are asking what is the order of the reaction. See, we know whenever you are writing rate is equal to k into a to the power of x into b to the power of y, x plus y is nothing but your order of reaction. So here what is x2, what is y, 1. So therefore order is equal to 2 plus 1, which is equal to 3. So we can say that order of this reaction is 3. Now the last one, find out the rate constant. Apply any of the equation. Let us take R1. We need to calculate what is K. So what is rate here? 1.2 into 10 to the power of minus 4 is equal to K into. So concentration of NO is 0.01 to the power 2. And what is concentration of Cl2? Nothing but 0.01 to the power of 1. Now to find out the K, send them to other side. We'll get 1.2 into 10 to the power minus 4 divided by 0.01. Can we take it as 10 to the power of minus 2? So we can write that. So this will become 10 to the power of minus 2 to the power 2 into, this also can be written as minus 2. Next, 1.2 into 10 to the power minus 4 and minus 4 you can cancel. This will become numerator. So we will get K value as 1.2 into 10 square. Now coming to the unit here. So either you can directly take n is equal to 3 and calculate. So how do you calculate? We know the formula. Mole to the power of 1 minus n, L to the power of n minus 1 into, so here second to the power minus 1. So we have calculated this earlier also. Let us take this. We know n value, substitute that and find out what is that. We can get it as 1 minus, here it is 3. So mole 1 minus 3 is nothing but minus 2. 3 minus 1 is 2 and s to the power of minus 2. So this will be your unit. So very simple. When you get the order that is 3, substitute in this particular formula to get the unit of this. So hope you have understood our chemical kinetics, rate law, rate constant and related numericals. So thank you so much.